When you open Vensim, this is the screen that you're gonna see. So the first thing that we're gonna do is we're gonna go and click New Model, okay? And whenever we are starting a new model, the first step is define our time setting. So here, the initial time is set as 0, and we're gonna leave it as is, but we're gonna change the final time to 60, okay? And the time unit, if you come down here, it's currently set at month, but we're gonna change that to day. So what it means is we're gonna run this model for 60 days. Okay, so that's how far our simulation model time frame is defined. One more thing that you need to think about is time step. So the default is 1, but we're gonna make it very small to 0.03125, okay? And what this time step does is it kind of breaks down the day into smaller pieces, and it defines how many times we're gonna calculate inflows and outflows and integrate that into the stock in a given time unit. So for example, if our time step is 1, okay, and time unit is day, that means we're gonna do that integration calculation every day. However, if we change it to 0.5, that means in a day, the integration will take place twice a day. Okay, so if we set it to 0.03125, that means we are getting a lot more fine-tuned result, okay, in our simulation model. Okay, say okay, and then we're gonna start by creating our stocks. Okay, so stocks use this special tool called level. So it's different from other variables. And because of stocks' very unique characteristics, this level is only reserved for stocks, and for stocks, you need to use this level tool, okay? So click that, and then you're gonna click wherever you wanna put your first stock. I'm gonna put it right here, and I'm gonna call that susceptible. Or I say susceptible population. And do you see that little circle in the corner? If you grab that, it's like a handle. You can adjust the size of your stock. And then if you put your cursor on top of your stock, it changes into a hand icon. You can grab your stock and move it around. Okay? Now, let's create the other stock, which will be infected population. Alright, again, I'm gonna grab it and then make it a little bigger. Right. Next, we're gonna create a pipeline that goes from susceptible population to infected population, and those flow rates are created using this tool here, the rates. Okay, so you see that it's a pipeline with that little valve. So this is reserved only for inflows and outflows. So click that, and the rate that we're going to create will be an outflow from susceptible population. So you're going to click in the middle of this stock and extend the arrow, and then you're going to click in the middle of your next stock, and then you're going to call this incident rate. Okay, let's say that you made a mistake. If you make a mistake with a variable name, then what you can do is you can click the variable and you can click whatever you want to change the name of, okay, and type in different name. But let's say that you made a mistake and then you want to remove something, then you're going to use this delete button, and you can actually delete some of the things that you have created. Let's say that you want to undo what you have done, then you can go to the edit, and then you can undo what you have just done. Okay, so we're going to create other variables, and those are done using this variable tool. Okay, so that's different from level. So here, first thing that we want to create is total population, or you could just say population. And what's going to happen is this population will be divided into two buckets of people. One is susceptible population, and the other one is infected population. So you only have those two options here, okay? So this defines the size of our population, and I believe in Ali's model, it is set to 80 million people, but depending on you know, how you want to simulate this model for, you can adjust the population size, okay? And then the next variable that we want to have is called contacts per day. Okay, so what this represents is the number of contacts a person would have on a given day. Okay, that's really important because that defines how fast the infection will take place. Okay, now using these two variables, what we're going to do is we're going to calculate contacts between infected and susceptibles. And this is important variable because this is where actually the infection is taking place. It's when people who doesn't have the disease come in contact with people with the disease, then some of those contacts will actually generate or lead to a new cases. Okay, so let's just move these around to create some more room. And then what we need is another variable called infectivity, which represents how many of these, or the percentage, which represents the fraction of these contacts which actually leads to infection. So this infectivity currently is set to 0.05, but which means that when there are 100 contacts between infected and susceptibles, 5 of them will actually lead to the infection of the disease. So depending on the disease that you are talking about, some of them will have higher infectivity while others will have a really low infectivity. So that's what this variable is about. Okay, now using this arrow, we're going to create the causal relationships. Okay, so now the contacts between infected and susceptibles, that's defined by number of susceptibles in the population. And you see that how I created the arrow. I'm going to show you again. So this is that blue arrowhead arrow tool. I start from the tail of the arrow, I click the variable, and I click midway, and now the arrow bends, and then I'm going to click the end point of my arrow. Okay, now I can change the size of the arrow or how it's shaped using this little tool here. Okay, and that's the contact between infected and susceptibles, and that's defined by number of susceptible population and contacts per day. Okay, so this is a total number of contacts that are made by these susceptible people. Okay, now let's rearrange these variables a little bit. I'm going to put my population right here. Okay, now we want to make sure those contacts are with infected people. So we need to calculate the probability of meeting an infected person. So that is based on the infected population over total population. So this is how the contacts between infected and susceptibles are defined. Okay, now out of those contacts, okay, a fraction of them will result in infection. So the incident rate is the contacts between infected and susceptibles multiplied by the infectivity, which will give us the incident rate. Okay? So this is basically our sketch. However, I want to add one more variable here, which will define the number of initial infected population. So in the beginning of the model, how many infected people are we starting with? Because think about it, if there is 0 infected population, so there is nobody with the disease, then this infection will never take place, right? So we need to have at least one person with the disease so that the whole, the infection dynamics can take place. So what we're going to do is we're going to create a variable called initial infected population, and we create this and link it to our stock, because usually when we have a stock, we need to let Vensim know what is the initial value of that stock is. However, we can define it within the stock, but if we pull out the initial value as a separate variable, it makes it a little bit easier to change it if you're running different simulations. So for example, in our current model, we're going to have the initial infected population as 10 people. Okay, so we're going to start with 10 people with disease. However, you can easily change this value to 1 and see what happens if we start with 1 person with the disease. Or we could test what's going to happen if we have 100 people with the disease. So when you pull out your initial value as a separate variable like this, it makes it a little bit easy for you to change those value of this specific parameter. Okay? So that's what we did here. Now, another thing that I want to do is add plus minus sign to our variables. The way that we do that is you're going to right click on the arrowhead. So for Mac users, it's going to be command click, and then it's going to open up a box like this. So now let's think about the relationship between infected population and context between infected and susceptibles. So then, higher the infected population, we're going to end up with more context between infected and susceptibles. So that's going to be a plus sign, like this. Also, if we have more people in the susceptible population box, then that contact number will go up as well. So we're going to put a plus sign here. Okay. Higher the number of contacts per day, then we're going to have higher number of contacts that are taking place between infected and susceptibles. So that's going to be a plus sign, right? Currently it's set at 15 contacts per day. So we are assuming on average, I know some people will make a lot of contact because of their job or lifestyle. Other people barely meet anyone, or depending on days of the week, some days you are really busy and you meet a lot of people, other days you don't. But here what we are talking about is on average. What is the average number of contacts that are taking place at the system level? Okay? And so higher the number of contacts per day, there will be more contacts that are taking place between these two populations, and that's going to lead to a greater incident rate. And of course, higher the infectivity, we're going to have higher incident rate as well. Okay, so this is the plus minus sign that we assigned. I'm just going to leave these two as is, because first of all, this one is just initial value. Population, I want you to think about how this affects the context between infected and susceptibles, because bigger the population, that means, hang on a second, you're going to end up with a greater number of people in this bucket of susceptible people, right? So that means that you're going to have more contacts between infected and susceptibles. Having said that, bigger the population, the fraction of infected people within that population will get smaller. So the chances of having contact with infected people become smaller in this case. So, in that sense, it's going to have a negative influence on the context between infected and susceptibles. Okay. And then another error that we want to create here is this link between population and susceptibles, because the initial value of the susceptible population will be the population minus initial infected population. Okay, so that is also needed. So these arrows, okay, are just existing there because we are using these two variables to define the initial value of our two stocks. So this is our sketch. So before we move on to define our equations, let's save our model. Okay, so you're going to click the save icon and determine where you want to save your file. Okay, so I'm just going to go to my desktop. Okay, COVID-19 model steps. Okay, and inside this, you're going to say this is a step 1 or it's a module 1. Okay, so I'm going to create this file. And we are ready to define our equation. Okay, let's go and define our equation. First, you're going to click this equation icon here. And all the variables that requires us to define the equation or the value will light up. Okay, now let's start with the population. So as I said before, Ali's model has 80 million people. Okay, so you need 7 zeros. Okay, there are no commas in your number, and the unit's gonna be persons. So make sure that if you say person, then use person throughout the model. If you're gonna say people, then use people throughout the model. If you're going to use persons with an S, then use that same form throughout the model. Okay, so that FENSIM knows it's referring to the same unit. Okay, click OK. Now, I'm going to show you what happens if you click this variable again, because now you see how the number 80 million has changed into a weird form, right? It just means 8 with 7 zeros. Okay, so it's a shortened form of writing that number. And then also note the type of the variable is constant, meaning this value isn't going to change throughout the simulation. Okay, so we're just going to assume that population is set at 80 million and there is no change within the 60-day time frame. Okay, now what we're going to do next is we're going to define initial infected population, and that's going to be 10. Okay, so again, the unit's going to be persons. You're going to click OK. Let's go and see our first stock, susceptible population. And what you're going to see here in the intake box is minus outflow. For every time step, FENSIM's going to calculate what the incident rate is, and it's going to subtract that number from susceptible population. Okay, so what you need to do here is define its initial value. So at time 0, what is the susceptible population? We need to let FENSIM know, and that's going to be, you see the variables here? Those are the list of variables that are connected to the susceptible population using these blue arrows. Okay, so it's gonna be population minus initial infected population. So that's gonna be the starting point of our susceptible population. Okay, the unit again is gonna be persons. You can click OK. Now the other stock, infected population, if you open that, instead of saying minus incident rate, this one just shows you incident rate because it's an inflow in this case. So for every time step, Vensim's going to calculate what incident rate is, and it's going to add to the infected population. Okay, the initial value is going to be initial infected population. Again, here, instead of putting that, you can choose to put number 10 in the initial value, but again, you will later see that makes simulation run not as flexible to changes or testing with different initial infected population number. Okay, so we're just gonna leave it like that, and then in the units you're gonna say persons. Okay, clear? Okay. Now the next variable that we're gonna define is contacts per day, and then we're gonna say it's gonna be 15, and then the unit's gonna be contacts per day. Okay, so this is a number of contacts a person would make in a given day, and then the contacts between infected and susceptible is gonna be susceptible population. You see all these variables here? I'm just gonna click those. Susceptible population multiplied by contacts per day. This gives us the total number of contacts that are made by susceptible population, but then we're gonna multiply that with the fraction of infected population within the total population. So it's gonna be infected population divided by population. Okay, so now let's think about the unit. This one, infected population and population, they are both persons, so they cancel out. Okay, this one is persons, this one is contacts per day, so you multiply the two, so it's gonna be persons times contacts per day. That's my unit. Okay, all right, now the infectivity, we're gonna say that's gonna be 0.05, and then the unit's gonna be, it's a fraction, right? It's a fraction of a contact, so we're gonna say that's 1 over contacts, right? And then the incident rate is gonna be contacts between infected and susceptibles multiplied by infectivity. So this will give us number of infections that's actually happening on a day. So now the unit's gonna be, this is person times contacts divided by day, and this is 1 over contacts. So if you multiply the two, then you are left with persons per day. Okay, click OK. Now we're gonna save the model. Now we are ready to simulate our model.